In the name of God, in this session we are talking about growth hormone, or the other name of it is somatotropin. Somatotropin or growth hormone is one of the main and major and the most important hormone of the uh, anterior pituitary. In this slide, we see the location of the pituitary and its connection to hypothalamus. Pituitary consists of two different lobes, the anterior part and the posterior part. One of the characteristic of pituitary is that it's composed of two different parts with two different origins. The origin of the posterior part, which has two different hormones, ADH or antidiuretic hormone, and oxytocin, is nervous system. But the origin of anterior pituitary, which consists of five main cells which produces six main hormones of anterior pituitary, is not from nervous system. Embryologically, it contains it's compromised of the epithelium of the pharynx. So we have the epithelium of pharynx in the anterior pituitary, in the middle of the nervous system. And one of the most important cells of the anterior pituitary is somatotrope cells, which are producing growth hormone or somatotropin. In the second slide, you see the location of the pituitary. It's not located in the middle of nervous system, but we are talking that pituitary is very important for controlling the function of the many organs, especially growth hormone is very important because it's an important factor for the growth and division of the cells in every organs. How it's possible that an isolated organ, an isolated gland like pituitary, which is located in the border of the CNS, can produce very important hormones that can control the body. We can say that it's not the pituitary which is aware of every part of the body, because normally the information which arrives from the peripheral to the central nervous system cannot feed back directly to the pituitary. But the connection of pituitary with the hypothalamus is the some part above of the pituitary. They are connected with the stalk through the stalk of the hypothalamus. This connection is very important for controlling the release of the pituitary hormones, because hypothalamus is the integration of the central nervous system, the center of many function in the body, like sympathetic or parasympathetic nervous system, controlling the temperature of the body, controlling the appetite or thirst, and even the circadian rhythm of the body is located in the hypothalamus. So hypothalamus is the integrating part of the central nervous system. Because of that, it can control the release of the pituitary hormones through two different factors or hormones. Sometimes it's the releasing hormone for the pituitary hormones. Sometimes it sends an inhibitory factor. For growth hormone, because growth hormone is very important in the body, the hypothalamus sends one inhibitory hormone and one releasing hormone for controlling the somatotrope. There is another hormone very similar to somatotrope in the anterior pituitary. Its name is prolactin. In the third slide, we can see the structure of growth hormone. And in the other slide, we can see the prolactin structure. By comparing these two hormones, we see that prolactin is very similar to growth hormone. Indeed, before 1970, the scientists don't know about the existence of the prolactin in the body. because the amount of prolactin is very lower than the amount of growth hormone, and the kids cannot detect the prolactin. Prolactin is a hormone which is responsible for the cell division, but not in the whole body like growth hormone. Just for some special organs like breast, like the sex organs, not only in the women but also in the men. So we have a little a basis level of the prolactin in the non-pregnant woman, which is small, it's not very high, and also in men. But during pregnancy, the level of the prolactin in the pregnant woman will getting high. Prolactin is essential for decoration of the breast and for preparing milk synthesis in the breast, and also in the uterus. It's very important. And the sex function in both male and female is under the control of prolactin. Normally, prolactin it's inhibiting by dopamine. So the control of the hypothalamus for prolactin secretion in the pituitary is a negative signal. It's through dopamine. We have a life pattern of growth hormone. In the next slide, we can see the life pattern of growth hormone throughout the life. Normally, before birth, we have some increasing level of the growth hormone because the different organs of the fetus are preparing. And after childhood, it will go to the steady state level. But the main peak of growth hormone is before puberty. And after puberty, we have a decline of growth hormone. The sleep of this decline is very important for the pattern and for the appearance of the person, because growth hormone is an anti-aging hormone. And if the steep of lowering and getting or declining of growth hormone after puberty will be very steep, it means that the appearance of the person is looking um, uh, older than his real age. But in contrast, if the steep is not very this decline is not very steep and gradually it will go to the decline, it means that the appearance of the person is looking younger than his real age. And we must notice that even during a senescence, very old persons, the level of growth hormone is not it's not even going to the zero. We have always some level of the growth hormone. Growth hormone is anti-aging of not only physically but also mentally. Growth hormone keep the brain sharper, and the mood is better when the growth hormone is higher. But when growth hormone is low, the person is it's normally depressed, very low or lack of the energy. He has no motivation for doing anything, and very all the time they are fatigued. These persons with a low level of the growth hormone. In the next slide, we can see the effect of growth hormone on the body weight of the animal. They are about the rat animals. Normally, rat animals during the 200 days after birth, their puberty will be completed. And we see that in control group, normally no more increasing in the body weight. But after injecting more growth hormone in these animals, even after puberty, we can see that the body weight is increasing. It shows that the effect of the growth hormone on the body weight. Um, Growth hormone is a metabolic hormone. What does it mean? Some hormones are metabolic and some hormones are not metabolic. If they have some effects on three different main substances in the body, I mean proteins, carbohydrates, and lipids, these hormones are metabolic. So growth hormones has several metabolic effects. We are seeing about its effect on proteins. Growth hormone is essential for synthesis of proteins, and it inhibits the catabolism of proteins. Growth hormone, the first step is letting the amino acid, the fuel for making the proteins into the cells. In this action, growth hormone behaves like insulin, because insulin also lets amino acid transport through the cell membrane. And after that, it enhances the RNA translation for protein synthesis, and even during longer time, it's lets more transcription of DNA to form more RNA. Also, I was talking about decreased catabolism of proteins. So, in the presence of the growth hormone, the proteins will be conserved in the body, no catabolism of proteins, and not only it conserves the previous proteins, but also promotes the synthesis of more and more proteins in the body. How about the fat and carbohydrate? The, in the presence of growth hormone, the free fatty acids will be released, so it enhances fat utilization, and more free fatty acid will be released to the bloodstream. And after that, they will go to the cell body and transfer to acetyl coenzyme A. So, because of that, in the presence of growth hormone, the cells are using free fatty acid instead of glucose. So the source of energy in the presence of growth hormone is not glucose or carbohydrate. It's just fat or free fatty acids. But how about the carbohydrates? It's the level of glucose, because glucose cannot enter into the cells in the presence of the growth hormone. So the level of the glucose in the blood circulation will be increased, and not only it also causes more and more glucose production in the liver. So what will be the reaction of the body? It's a condition like diabetes. Because of that, the body tries to increase insulin secretion from pancreas, but this insulin in the presence of growth hormone cannot let glucose to enter cells. So because of that, glucose level will be high. Normally, because the level, we have some fluctuations going up and down in the level of growth hormone. So no, for no long time, the presence of the growth hormone will be appear in the body, and because of that, normally we don't have a diabetes. But if we have some tumors, some cancers in the somatotrope cells, the level of growth hormone will remain high for a very long time, and because of that, these persons are prone to getting diabetes. So we see that insulin and growth hormones are two main hormones, two main metabolic hormones in the body. Sometimes they are working together, we call them agonists, and sometimes their action are opposite, we call them antagonists. In the metabolic form, using protein, they are agonists because both of them, insulin and growth hormones, let amino acids enter the cells, and they promote production of more proteins. But for the considering carbohydrate and glucose, they are antagonists. Insulin try lets glucose enter the cell and use as promote cell to use glucose as the source of energy, but growth hormone will not let them, so they are antagonists. I was talking about growth hormone and aging. And the other thing that I want to talk about is how growth hormone increase the number of cells or promote growth in three different main targets: in the muscles, in the bone, and in the fat. Normally, in the bone, the chondrocytes they don't have the receptor for growth hormone. How we understand this? Because in vitro condition, I means that in the culture of the chondrocyte, if we increase or add growth hormone, we will see no reaction. It means that the chondrocytes or the bone cells they don't have receptors for growth hormone. But if we inject the growth hormone in an animal, we can see that the bone size will be increased. How it's happen? How it's happening? It can be through a mediator. There must be some molecule transiting between growth hormone and the cell or bone cells. In this slide, we see that the pituitary, after increasing secretion of growth hormone, the growth hormone will go to liver, and it's promote or it will trigger the synthesis of one factor, insulin-like growth factor, or with the abbreviation of IGF. We have four different IGF in the body. The most important part is IGF-1 or somatomedin C. The other name is somatomedin C. This factor has some receptors on different organs, especially in bone cells. So this is the mediator between growth hormone and the bone cells. I was thinking that all the hormones which are under the influence of the axis between pituitary and hypothalamus, normally they have some fluctuations going up and down during the night and day because they are under the control of the light. We see that these fluctuations in the level of growth hormone from 8 a.m. to the next 8 a.m. after 24 hours. But sometimes we have the amplitude of the growth hormone is very important for us. This amplitude determines the anti-aging action of growth hormone. Everything that triggers this amplitude is good and beneficial for your body because it promotes or it's increase more and more secretion of growth hormone, so your appearance will look younger. In this slide, you see that one of the most important stimulator of growth hormone is strenuous exercise, and after that is sleep. So two good things for triggering growth hormone secretion is one is sleep, but not sleep during day. This sleep must be during night. So the sleep during night is good. The other thing is that the condition of your nutrition that can determine the synthesis of growth hormone. When you have calorie deprivation or shortage of calorie usage, the level of growth hormone will increase. In the next slide, you see that the calorie restriction is specifically sensitive to protein deficiency, not carbohydrate deficiency. At first, we see that very high level of growth hormone, which is not normal. This is the pathological level of the growth hormone in protein deficiency patients or kwashiorkor patients. After that, for 3 days, the persons get just carbohydrates. So the calorie deprivation it's no more remaining, but we have still protein deficiency. What happened to the level of growth hormone? Nothing. So it shows that the high level of growth hormone it's not just due to calorie deprivation, it's due to protein deficiency. And after that, for more 3 days, the patients get more protein treatment, and we see that a sudden decrease in the level of growth hormone. The level of growth hormone is going to the normal level, and after 25 days, it's getting really normal. So, in the next slide, we see the regulation of growth hormone, some stimulation. The most stimulating thing is about the nutrition. When we have glucose decrease or free fatty acid decrease or calorie decrease, all of them, fasting and calorie deprivation, all of them cause more and more growth hormone secretion. The only nutrient that cause or stimulate growth hormone is amino acid. It means that um, taking more and more food, and especially getting some snacks, and not having enough time between your regular meals, it's not good for growth hormone secretion. The best thing that you can use as a snack is just protein in the form of amino acid. And the worst thing which can subside the growth hormone secretion is sugary things and fat lipid or fatty things. Any stress or trauma cause some growth hormone secretion, and sleep and exercise. We were talking about that. Stage 2 and stage 4 of the sleep, especially sleep during night, they are good and regulate growth hormone secretion. Puberty, because of the sex hormone, either estrogen or testosterone, both of them are good. What is the ghrelin? Ghrelin is the other stimulant for growth hormone. This is a hormone which is normally secreted from stomach during starvation. When you are hungry, the ghrelin is increasing, and one action is that the person is a hunger person is seeking for food. The other thing is it goes to the hypothalamus and also to the hypophysis and stimulate the secretion of growth hormone. There are some neurotransmitters which are stimulators of growth hormone, like dopamine, serotonin, acetylcholine, adrenergic with the receptor alpha, and the enkephalins, the normal innate opioid system inside the body. But there are some growth hormone inhibitors like somatostatin, and also when we use the food full of glucose, sugar food, very fatty food, or during aging, during obesity, and during using cortisol like dexamethasone, more cortisol than normal cortisol in the body from the outside, and also during pregnancy. Why during pregnancy the level of growth hormone in the body of mother will must be sustained? Because during pregnancy we have three different source for growth hormone. One is the growth hormone from the hypothalamus hypophysis axis of the mother. The other is growth hormone secreted by the fetus, and the other thing is are some factors like growth hormone secreted by the embryonic membrane, and also inside the uterus. So because of that, the level of the growth hormone inside the body of the mother must be sustained. Here we see the effect of the ghrelin on the secretion of growth hormone. Normally, we have two different hormones controlling your body weight in the long time. One is ghrelin or hunger hormone, which is secreted inside the stomach during starvation. The other thing is leptin, which is normally secreted by the fatty cells inside the body. The signals of the leptin is to inhibiting the appetite in the arcuate nucleus or the center of the appetite inside of the hypothalamus. The signal of ghrelin is increasing appetite during some positive signals which is sending to arcuate nucleus. So they are in combination or in contrast. But in this slide, we see the effect of ghrelin for secretion of growth hormone. Ghrelin is not increasing some appetizer hormones inside the hypothalamus, but also it increases the level of growth hormone, the releasing hormone, the factor from the hypothalamus, which stimulate the secretion of growth hormone, and also it's go directly to somatotrophs cells in the pituitary, and directly stimulate the secretion of growth hormone. So indirectly to secretion of GHRH, and directly by going to the pituitary, it increases the level of growth hormone. It's not only increase the level of growth hormone, but also go to the arcuate nucleus, the center of the for controlling the appetite inside the hypothalamus. It increases the level of agouti-related peptide and neuropeptide Y in arcuate nucleus. Both of them increase the food intake. So, but on the other hand, in the final slide, in the next slide, you see that ghrelin as an appetizer hormone and leptin as an inhibitory hormone for controlling the body weight. They must be in organized well. They must be working together in very fine tune. It seems that the controlling of your body weight, it's exactly like a tango dance, which are controlled. One partner is grilling, the other partner is lifting, but this dance must be matched by what? By growth hormone. So the growth hormone is the leader of the orchestra for controlling this dance between grilling and lifting. When the level of growth hormone is disturbed, for example, a person who are working during night and sleeping during day, the level of growth hormone will be disturbed in these persons. And what will happen? Normally, the balance between ghrelin and leptin will be disturbed, and normally the level of ghrelin will be up. So the appetite of these persons will be increased, and the body weight will be going. And in the gigantism, sometimes we have some abnormality in the level of growth hormone. If we have some tumors in the growth hormone before puberty, the person will be very high, and this person we call it the gigantism. And little by little, the person will go through the diabetes, and the lifespan of this person is not normal. But sometimes have acromegaly. Acromegaly means the some tumors in the or adenomas in the somatotroph cells before puberty. In these persons, sorry, after puberty. In these persons, because the diaphysis is closed and no, we will have no more increase in the length of the high bone. What will happen? There are some surface bones that can increase its size, not in the height but in the transverse. These bones are the bones in the cheek, in the eyebrow, and around the orbit, and also the mandibular. Not only so the appearance of the persons little by little will be changed, and also the bones in the hands and foot will be increased. The size of the foot, uh, the foot shoe size will be increased in these persons. This is because of the increasing the in the bone of the foot. And also in the soft organs like the heart, the tongue, and the inside soft organs, this increase will be happen. So in the final slide, you see a person with acromegaly that the start of the age of the start was 16, but in 23 you see that the appearance of the persons has been changed, and at 44 completely changed. It's completely abnormal, but after removal the tumor, the appearance it's getting better. Okay, if you have any questions about this session, please send me, and I will. I hope that after Ramadan and after coming back to the universities, we will have some sessions for remove, for a problem. If you have any problems, that for solving the problems of the students. Okay, thank you for your audience. Goodbye.